Hello everybody. So this is our second lesson. Last time we just did some very simple things like learning a little bit about the number line and comparing numbers. And so if there are any questions over any of the topics covered last time, be sure to email me your questions. I've graded a good bit of the worksheets. I've been going through them. They look good. There's been a few simple mistakes with opposites and reciprocals, but we could work that out. Or you could probably just check the answer key and see your mistake and probably without even much explanation gain a deeper understanding of that. And so today's lesson, we're actually going to hit a few really easy topics as well that some people get really confused on. So this test used to be or usually is no calculator. So this is a section that I usually say please pay a lot of attention to because a lot of people struggle with using operations, just adding, subtracting, multiplying, dividing when we start throwing in negatives and positive numbers. So that's actually what we're going to do is we're going to hit adding, subtracting, multiplying, dividing. So like I said, this first chapter is all a bunch of review of stuff that you should already know. But let's jump right into some examples to talk about adding. So if I were to just simply put this problem up, 2 plus 5, almost everybody in the class would know off the top of their head that's 7. And they would know that without much stress or much thinking or much, some people probably grab their fingers and count it. I have taught a class where I've asked something that simple and several people reach for a calculator. I'm almost passed out, almost fainted from shock. But 2 plus 5 is 7. That's really simple. What I want to talk to you about is people get more confused when we start adding negative numbers in there. So instead of just 2 plus 5, how about 2 plus negative 5? So I want to show you a really simple way to add that if you get lost or if you get really anxious on the test, you could just kind of zone back down to something very simple. So adding is just telling us this is where we're starting, the first number. Adding is telling us how much we are moving and in what direction, depending on whether it's negative or positive. So look at this. This is saying, hey, we're starting at 2, and we are moving negative 5. Now, which direction is negative? Remember, negative would be moving back to the left. So from here, we're moving 5. 1, 2, 3, 4, 5. So without any skill of adding negative or positive numbers, I can see that this is going to give me negative 3. Now, I thought about this a few years ago when I was trying to think, how did I add negative and positive numbers in my head without having to stress too much? And it's because I started this way, visualizing it kind of as a movie number thing where I'm at 2, I'm going to move back 5 because it's negative 5, and back 5 in my head, I guess I visualized the number line would be back until we hit negative 3, it would be back 5 spaces. Okay, so that's one way to do it. Another way to do it is to memorize all these strange rules. If you are a rule memorizer, I will go over all the rules in a second once I do 2 more examples. Okay. So let's see. So what if I did negative 2 plus 5? And let's change the color on this one so that I can use my number lines in different colors and you'll know which one goes with which. So negative 2 plus 5 equals. So this time we're going to start at negative 2. It'll be in blue. And we're going to move 5, and it happens to be positive 5. This direction is the positives. So 1, 2, 3, 4, 5. And so we will get an answer of positive 3. That's pretty simple, right? And let's do one last one in green. What if they're both negative? Negative 2 plus negative 5. Well, what's that going to equal? We could do the same thing. We're starting at negative 2. Boom. And we're going to move back 1, 2, 3, 4, 5. We moved negative 5. So that will give us negative 7. Okay? So you can use a number line to reason through this. But if we wanted to talk rules, notice if they have the same signs, like 2 plus 5, we could just add and you get 7. If they had the same signs, like 2 plus 5, we could add and get 7, but notice that we keep the same sign. So these are both positive, so we get a positive 7. These are both negative, so we get a negative 7. The difference comes in when they are different signs. Notice these are different signs. One's positive, one's negative. If you wanted a rule, which I strongly discourage, I'd rather you understand than memorize rules, but if you are that type of learner, ignore the signs for a second, subtract them, and then once they have been subtracted, take the sign of the bigger number. So 5 is larger than 2, so this will be a negative 3. 5 is larger than 2, so this will be a positive 3. So that's one way of memorizing steps or memorizing a way. Another way to add and subtract or add negative numbers is to think money. That helps people conceptualize negative and positive dollars all the time. So say you have $2, you're going to add $5 to it, you're going to gain $5. You know you have 7. Say you have $2, you go out to lunch and it is $5. Do you have enough money? No, you're going to be in the whole sum. You are $3 short. Say you owe me $2, but you bring a $5 bill, you have $3 extra left over. You owe me 2, you borrow 5 more, now you owe me 7. So thinking of money does help some people conceptualize negative and positive numbers. Okay, some people do all these 4 in their head really quickly and easily. Some people need to use a number line or memorize rules or think money, or just sometimes people just take a few minutes to grasp these. Okay. Now, the next thing we want to do is work on subtracting. And I want to tell you something for this course. I literally could teach this course with only 2 operations. I could teach you the entire course with adding and multiplying if I wanted to. That's because subtracting really isn't its own thing. Subtracting really is not. Wait a second, here's going to come one of the words that we worked on last lesson. Subtracting is really just adding the opposite. Okay, and that's the word one of the words we worked on last class. I told you they'd pop up again. And here's what I mean. You remember in high school, if you walk down a high school hallway and there's math lessons going on, the teachers are screaming things to you like keep change, or keep change switch, or whatever your teacher said. And so some people cling to that and kind of don't cling to that idea. I know it's adding the opposite to subtract something. So for example, if we were going to do some subtractions, and let's use 3 and 7. If I said 3 minus 7, some people are going to struggle with that because we're subtracting off a bigger number. But adding the opposite, so what subtraction is it's just adding the opposite. So you keep the first number the same, and we're going to turn subtraction into adding the opposite sign. Well, this was a positive 7, so we're going to turn it into a negative 7. And then these problems become exactly the problems that we just did. I'm starting at positive 3. I am going back 7. 1, 2, 3, 4, 5, 6, 7. So there I am at negative 4. Okay. What if I did 3 minus negative 7? Once again, if you remember that subtraction is just adding the opposite, I'm going to turn the subtraction into adding the opposite. Well, this is a negative 7. What's the opposite of negative 7? A positive 7. So you see, if you have the skills to know what an opposite is, you can turn every confusing subtraction, because this confuses people. This confusing negative minus, or minus a negative, confuses some people. If I can turn every subtraction into adding the opposite, well, that becomes adding a positive, which is a lot easier because 3 plus 7 is 10. We don't even need to use the number line to find that one. Okay, let's keep mixing up some things. How about negative 3 minus positive 7. And you say, oh man, that's a little bit confusing, but it's not all that bad if I just say, okay, well, let's turn this subtraction into adding the opposite. What's the opposite of positive 7? Negative 7. So I turned it into adding the opposite. Negative 3 plus negative 7. If you were at negative 3 and you move back negative 7, you're going to be at negative 10. Or you could have memorized the rule where they have the same sign. So adding things with the same sign, you just add it and take the sign. Let's see, I think I have one more variation or combination here to try. What do I get? Negative 3 minus negative 7. Well, we can do the same thing we've been doing. Keep the first number the same. Turn this subtraction into adding the opposite. Well, this is negative 7. What's the opposite of negative 7? Positive 7. So I'm starting at negative 3, and I am adding positive 7. So I am moving 7. And if you wanted to take the time to count, I think you would see that moving 7, let's see, 1, 2, 3, 4, 5, 6, 7. 7 is going to be positive 4. Okay? So you can add, if you can add, you can subtract positive and negative numbers. Now, yes, you're going to be allowed a calculator because it's just too difficult to make sure not everybody is not using a calculator on the first test. But I do want you to be able to do some of these without having to reach for a calculator every single time. That would get kind of difficult and tedious. All right, let's talk about multiplying and dividing now. So the whole point of this lesson is with negative and positive numbers. I'm pretty sure everybody in here can multiply positive and negative numbers. Can multiply and divide positive numbers. For instance, if I say, okay, 2 times 4. Hopefully everybody's screaming at me, yes, we know that is 8. And if you're not used to this notation, a dot is the same thing as a multiplication symbol. So either one you feel like using is fine by me. Okay? So 2 times 4 is 8. But what about when I start mixing in negatives and positives? What's this one? Or what's this one? Or finally, what's this one when they're both negative? I have a very simple rule for memorizing this. Okay, it's time for us to have a very serious discussion that our world has very wrong. Everybody, for some reason, likes to perpetuate this one lie that all babies are pretty. We know, it's a very serious moment, we know that this is not true. We know not all babies are pretty. You have seen some of them ugly babies. I promise you, there are ugly babies out there. Not always true. So there's a rule of nature that seems to go with whether your baby ends up pretty or not. Of course, when you get a beautiful mom and a beautiful dad and they multiply and have babies, those babies end up being beautiful. So I'm going to use positives. Positives are beautiful because it's positive to be beautiful, right? So when you have a beautiful mom, positive, times a beautiful dad, a positive, you get a beautiful baby, right? And there's also that strange, really weird exception. Have you ever noticed two of your friends get together and you think, oh, they should not be allowed to breed because they're both kind of ugly. But for some reason, two ugly people, their ugliness cancels out and they have pretty babies. It's the strangest phenomenon in nature. You look at those people and you go, how did you have that beautiful child? And it's just shocking. So much ugliness coming from the mom and dad, but the baby ends up beautiful. It's amazing. I think it's to help the family a little bit. Now, when do we get ugly babies? It's that weird phenomenon where the guy gets the girl that's way out of his league. You have an ugly dad and a pretty mom. I hate to say it, but you get an ugly baby. Or the other way around. You have a pretty dad and an ugly mom. You get an ugly baby. Okay? So when they are different, is when you get the negatives. Okay, so this is just a rule of nature. I'm sorry, if your baby's ugly and your woman or your man's really nice looking, it might be time to look in the mirror. Just real moment, real talk, real quick. All right, so we can use this rule of ugly and pretty babies for multiplying numbers. We know 2 times 4 is 8, so all of these are going to be 8, just either negative or positive in some way. Okay, so 2 times 4 is 8. There are opposite signs. One is negative, one is positive. Ugly mama, pretty daddy, that's going to make an ugly baby a negative 8. Over here, 2 times 4 is 8. Positive, negative. A pretty mama, an ugly daddy, that's going to make an ugly baby. Okay? 2 times 4 is, of course, 8. Ugly mama, ugly daddy. It's going to cancel out and give you a positive 8. I don't really need to write the positive, but I did anyways. Okay? So, with multiplication, you can go ahead and do the multiplication, then think about whether it is positive or negative. Okay? And all you have to do is look and see, are they the same signs? If they're the same type, they're going to have a pretty baby. If they're different, it's going to be a negative and ugly baby. Now, I wrote multiplying and dividing because all the same rules that applied to multiplying also apply to dividing. I wonder why that is. That's because dividing. Now here comes another one of our words. I told you I could teach this course with just 2 operations. I could teach this course with adding and multiplying, and I need no other operations. The reason for that is subtracting is just adding by the opposite. Well, dividing is just multiplying by the reciprocal. Okay, we will harp on this a lot more later. But what that means then is all the same ugly and pretty baby rules apply. Okay, we're not going to use the reciprocal thing too much here. But that allows me to do some examples. Because the same ugly and pretty baby rules will apply to multiplying and dividing. The reason is because dividing is multiplying. We will talk about why it is multiplying that by the reciprocal much later in the course, and it will be a big point. Okay, so what is 10 divided by 2? That is 5. If they are both positive, we will get a positive. Pretty mama, pretty daddy, pretty baby. 10 divided by 2 is 5, but they are different signs. Ugly mama, pretty daddy, that's going to give you an ugly baby. Same thing with this one. 10 divided by 2, pretty mama, ugly daddy, ugly baby, I'm sorry. It just happens. We know there are ugly babies out there. And here, 10 divided by 2 is 5. Ugly mama, ugly daddy, somehow get the pretty baby. Okay? So I hope you're with me. I hope you're doing okay. We can now add, subtract, multiply, and divide negative and positive numbers. We should be feeling solid on that. Well, then I have one more topic to kind of introduce. I think we'll hit this harder in our next lesson, but we're just going to start with a very simple idea then. Dividing, when we start dividing numbers, this opens up the door for everybody's, well, there are 2 F words in algebra, and the first F word that people are terrified of is fractions. There's no, oops, I keep clicking weird things, fractions. There's no need to be terrified. There's no need to worry about it. But for some reason, people are terrified of fractions. I hope by the end of the course I can get you to see where fractions are way better than decimals and way more cozy and way more awesome. But it'll take you a while to convert over to the dark side if you are a strong believer in hating fractions. But hopefully we'll get you there. I have some people come up to me and tell me they like fractions way better after the course is over. So all we're going to look at right here is reducing fractions. It'll help us with later lessons. Reducing is not the fancy mathematical term. That's the lame kind of how we talk, you and me. It's getting a simplified equivalent fraction. So let's look at an example. 3 over 12. Does this reduce? You may not even know if it reduces or not. Okay, you may not be sure. You may have no clue. But here's the idea. If there is a number, if I could rewrite 12 and rewrite 3 so that they have an identical part on top and on bottom that cancels, that reduces, that divides to 1, I would like to jump on that. What do I mean by that? All we want to do is called something called factoring or factors. We want to see if there's any factors of 3 and factors of 12 that are the same. So kind of as a little side note here, I'll write this word in red, as the other F word is factoring, are factors the same on top and bottom. Now listen very carefully. The reason factors is an important word, that's the mathy word for this. That just means I'm trying to rewrite this as a multiplication. Okay? So for instance, 3. What are the only things that multiply to give you 3? 1 times 3. That's the only thing I can come up with to multiply to give you 3 as far as pretty numbers go, whole numbers, integers. Now 12 can be lots of things, okay? But let's not write, I don't want you to go with the whole factor tree and write out every single factorization of 12. Does 1 or 3, is that a factor of 12? And you should say, yeah, well 1's not going to give me anything, I don't care about 1. But 3 is, because I know that 3 times 4 equals 12. Okay, so I have rewritten 1, I have rewritten, that's hard to say, 12 as 3 times 4. Do you agree that everything's still equal and the same? That's good, because this is still equal to 3 on top, this is still equal to 12. Now look at what happens here. I have a 3 on top and I have a 3 on the bottom. 3 divided by 3 is just 1, or we can say, don't let other people hear me say this, we can say they cancel out. Now I can only do this if they are factors. What does that mean? If the only thing separating them from the rest of the fractions are multiplications. If there's a plus sign or a minus sign in between two numbers, I cannot do this. Okay, only multiplications separating these numbers, I can do this. So what are you left with? 1 over 4. So gee, I have a question. Are these two in the black and the red truly equivalent fractions? Why don't we just lazily check it in a calculator? Let me get a calculator. Alright, and let's check it. Let's see, what is 3 divided by 12? 3 divided by 12 is 0.25. So remember that. Let's check what 1 divided by 4 is. 1 divided by 4. It's also 0.25. So yes, they are equivalent. Now, are we done reducing? Is there anything else that I can break the top and bottom up into that'd be identical? No, there's not. Besides 1, but 1 doesn't count. Another way of thinking about this, another way of thinking, I like to provide a lot of ways of thinking is, just do a little light bulb. Is there a number that divides evenly into the top and the bottom? And so same process, because dividing is multiplying by reciprocal, it's really the same thing. Is there a number that I can divide the top and the bottom by evenly? And you should say, if you're doing it that way, oh yeah, the top and the bottom are both divisible by 3. So if I divide them both by 3, I can reduce this fraction down. 3 divided by 3 is 1. 12 divided by 3 is 4. Notice it works exactly the same way. I'm okay with you doing either way. I will go ahead and tell you. I will interchange these two without even thinking about it. Okay? I will do either of these, almost like breathing, without even giving much thought. Okay? So let's do a few examples and then we'll call it a day. So a few examples. One like this, 6 over 15. And you can ask yourself either of the questions, is there a number that divides evenly into both of these? And I'm going to say, yeah, actually the number 3 does. Because 6 is 2 times 3, and 15 is 5 times 3. Okay? If you're not good at coming up with these, spend some time kind of revisiting multiplication tables and trying to memorize some of those. That will help you be way faster at this. And so I'm left with 2 over 5. Are we finished? Yeah, there's no number that divides evenly into both 2 and 5. Do another example. I'll go over here so I have more space. 24 over 18. This one, if I ask you to do it yourself, some people, there would be two different ways of doing this one, okay? Some people would be a little faster than it. Some people would be a little slower. I'll show you the faster way first. Some people would say, oh, I know that 6 divides evenly into the top and the bottom. Here's what I mean. 24 is 4 times 6. 18 is 3 times 6. So the 6's are gone, and I have 4 over 3. Well, you may not have memorized your timetables very well, which I strongly suggest you know them. And so you may not know that 4 times 6 is 24. You may have said, oh, that's 2 times 12. So here is a slower way of getting there. Okay? It's an alternate path. You may say, okay, well, 24 is 2 times 12, and 18 is 2 times 9. Say you really like your 2 times tables. And you say, oh, look, 2's, there we go, 12 over 9. And then I'm going to ask you, are you done? And you're going to say, I'm done, I've reduced it. I'm going to say, you did not reduce all the way, because these two things are still divisible by a number that divides evenly into both of them. 12 is 3 times 4. 9 is 3 times 3. They are both divisible by a 3. So I can cancel out another 3. And I'll get 4 over 3. Now are you done? Yes. And notice that even if you take a longer path, you still get to the same answer. So I will tell you this. It is faster and easier if you can think of the biggest number that divides evenly into both of them. If you do not, you can take it in steps like I did on the bottom half here. Okay? So let's do another example. Let's see. Negative 25 over 30. If I throw a negative in there, is that going to mess you up? No. Because the sign doesn't really matter in reducing. Okay? This is still going to be negative. Well, is there a number that divides evenly into both? Yes, 5 does. Because 25 is 5 times 5. 30 is 5 times 6. So, these 5's are gone. Don't drop the negative sign. It's still there. So negative 5 over 6. Alright, let's do another one. One more, last example. And then now I'll be done. What about 21 over 42? This is one of those where you may forget or not quite remember to reduce it all the way, because most people know their 7 times tables, and they'll be excited to tell me, ooh, 21, that's 3 times 7. And I'll say, very good. And they'll say, ooh, 42, I know that one's 6 times 7. Okay? There's nothing wrong with taking extra steps to get there, and you're going to say, look, the 7 on top, 7 on bottom. I am good to go with 3 over 6. And I'm going to ask you, are you done? And you may say, yeah, and I'm going to say, no, you're not, because there is a number that divides evenly into both of these. Because 3 is 1 times 3, and 6 is 2 times 3. Ah, there's more there. So you just get 1/2. You could have noticed from the beginning, okay, if you are a very big thinker, you could have noticed that, oh, I know that 42 is 2 times 21. And so I can do 21 as 1 times 21 and then get the answer a lot faster. Doesn't matter which way you do it, no. I don't care if you take 7 steps to get there, as long as you get the right answer. Okay. Now make sure you go into Blackboard and do your worksheet, and make sure you do your My Math Lab. Alright, you guys have an awesome day.